Hello guys, my name is Willy Mateo. I am a computer science engineer. I'm from Ecuador. Currently, I am working as a full stack software consultant for Insight, that is an American biopharmaceutical company. And today, I will share you a revolutionary topic, designing systems with multi-agent architecture. Probably your first question will be, what is an AI agent? It's an autonomous system that uses AI to solve a specific problem. But why do architectures matter in AI? The first reason is the architecture defines how an AI system is structured, shaping its ability to perceive, reason, and act effectively. So the architecture defines the bones of our system. The architecture defines the core components, the internal tools, the inputs, the outputs, and how they interact with them to solve the specific user problem. The second reason is because there are many ways to solve a problem, but if we choose the right architecture, it will impact the system's scalability, adaptability, and efficiency. The third reason is related to the second one, because a well-designed architecture ensures that the AI solution is aligned with the complexity and the requirements of the system, of the problem that we want to solve. Probably your second question could be, how can I build an AI agent? There are at least 6 components of the AI agents. Obviously, the first one is the AI model, that is an algorithm that allows the agent to understand, analyze, and generate responses. The second one are the nodes. They could represent individual agents or specialized units that perform a specific task. I like to define the nodes as processing units because I can create a node, for example, to execute a programming code, another node to generate database queries and fetch information from that database, another node to fetch information from the web. Okay. Um, we have also the tools. The tools are similar to the nodes. They are also processing units, but they are external resources or APIs that the agent can use to extend its capabilities. We cannot invoke the tools by ourselves. We need an AI model for that. It could be an OpenAI model, a cloud model, a DeepSeek model, whatever we want. So the AI model will analyze the user problem and will decide if it's time to execute 1, 2, or 3 tools, or maybe 0. The edges, they define the connections and communication paths between the nodes, enabling coordination. We can create a direct access, for example, to connect the node A with the node P, or we can create conditional edges. The state is the internal memory of our agent. It's the current context of our agent, and we can use the state to make consistent decisions. And finally, the prompts. They are so useful because they are instructions or inputs that guide the behavior of the agent and shape its output. For example, I can create a prompt to say to the agent, you are a senior developer. Your task is to help the users to fix bugs in their web applications. Okay? It's like to create a role for the agent. The easiest way to create and build an AI agent is using a single agent architecture. It works independently, handling all decision making and problem solving on its own. It's pretty simple to design, understand, and control, but a single agent architecture is limited in scalability and adaptability. Depending on the requirements of our project, depending on the problem that we want to solve, we could implement a single agent for production application or could not. I want to go deeper in the problems with the single agents. Let's suppose that we are building a single agent architecture and we add too many tools to that agent. Okay, for example, one tool to generate queries and fetch information from a database, another tool to generate an image, another tool to generate a video, and then another other tools. So we will realize that the agent will start to make poor decisions about which tool to call next. It's like a human. If we offer the humans too many options to decide, in this case, the agent doesn't know which tool to call next. Okay? If we add too many components to the single agent architecture, the context grows too complex for a single agent to keep track of. This is because there is a need for multiple specialization areas in the system. For example, there's a need to create an agent that is an expert as a planner, as a researcher, as a math expert, as an image generator, as a video generator, and then this is because we have the multi-agent architecture that solves most of the problems with a single agent architecture. In this case, the multi-agent architecture consists in several autonomous agents, many agents working together or competing in a shared environment. Each agent, remember, each agent has its own knowledge and goals, but interact with others to solve the complex problem of the user. And as a developers, as our task is coordinate all of these individual agents in a shared environment that is a multi-agent architecture to work together to solve the complex problem of the user. Okay. There are a lot of benefits in the multi-agent systems. First is the modularity, because separate agents make it easier to develop, test, and maintain. This benefit is related to the second one, the specialization, because we can create expert agents in specific domains, in specific areas, to solve a specific problem or to solve a specific part of the problem. For example, we can create an expert agent that it's an expert generating images, another expert agent to generate videos, another expert agent to search on the web, another expert agent to analyze the context of a document. And then, okay, with this approach, we keep the concerns separate. The control. This is the final benefit because we can control how the agents communicate. This is our task as developers because we need to coordinate the communication between all of these single agents. For example, we could say the individual agent A will be first, then we'll pass the control to another agent, and then I like to execute all of these agents in parallel, and then we can create our custom agent architectures. Okay, we can coordinate the communication between the agents. But obviously, as uh, everything approach in the multi-agent systems, there are challenges. The first is the execution time, because it will be increased because the system needs more time to analyze the problem, understand the problem, and create a path to solve the problem, the user input, the user requirement. Okay. Obviously, we need more time to invoke the agents and wait for this execution and wait for their results. The development time is also higher because since the architecture must be carefully designed, each agent must be implemented and coordinated. As I mentioned before, as a developers, we need to analyze the problem, understand the problem, and design the solution. In the designing process, we need to carefully design the communication between the agents, the coordination, which agent should be first, which agents should be at the final, or what will be the inputs, what will be the outputs, and then how to handle the exceptions and another errors, maybe. This is because we need more time to develop the agents, the architecture. The operational costs rise because multiple agents mean more model calls. As we know, if we want to use the OpenAI API, the OpenAI models, the cloud models, the DeepSeek models, or whatever model we want to call, uh, those models, those invocations are not free. We need to pay for that. This is because we need to care about the operational cost because the billing is related to the tokens that the agent generates in the inputs and in the outputs. And finally, the coordination complexity. As I mentioned before, our task as a developer is to coordinate the agent's communications. So we need to decide which agents should be called in a parallel execution, which agents should be called step by step, or which agents should be called concurrently. Okay, but the goal is all of these agents should be work together. One of the interesting topics is the communication in multi-agent systems. So the question is how the communication happens in the multi-agent systems. We can declare the individual agents and we can invoke the individual agents using tools or using nodes because the tools and the nodes are processing units. And do you remember that each individual agent has its inputs and its outputs? So we need to define the source agent, the target agent, the input, and how to handle the output. A common pattern is the use of handoffs, where one agent passes the control and the context to another agent to continue the thinking process, the analysis process about how to solve the user request. As you can see in this diagram. So each agent executes its steps and then decide whether to finish. If it's time to, if I have enough information to return the final response to the user, and it's time to final the execution, or route to another agent, pass the control to another agent to solve another small part of the problem, or even loop back to itself. We can use the edges, the communication paths to create flexible and dynamic iteration between the agents, between the nodes, and between the and inside the multi-agent architecture, as you can see in this diagram. There are a lot of agent architectures, are a lot of approaches to build agent architectures, but there are 5 common multi-agent architectures that we want to use to build our agents. The first is the network, the second the supervisor, the second the supervisor using tools, the hierarchical, And also we can create our custom architecture to solve our complex problem. Okay, so let's start analyzing the network architecture. In the network architecture, the agents are defined as nodes. So each agent can communicate with every other agent. Each agent has connections to all of the other agents. So each agent can decide which agent to call next. This architecture is good for problems that we don't have a specific path to follow to solve the complex problem. This architecture is good when we don't have a clear hierarchy of the agents of a specific sequence in which agents should be called. This is because this agent has the network name because it's a network, okay? So let's suppose that we are building a travel planner agent, as you can see in this image. We can implement a starting point to fetch the current time of the city that we want to visit. With this information, with the current time information, I can pass the control to another agent to fetch the hotel's availability. With the hotel's availability information, we can pass the control to another agent to create the travel itinerary. And then we can iterate between this architecture depending on the user request, depending of the hotel availability, the current time, depending of all of these factors, okay, depending on the current context of the agent. In the supervisor architecture, we define the agents also as a nodes, but there is a supervisor node that uses an LLM and AI model, that decide which agent node should be called next. For example, let's analyze this architecture. Let's suppose that we are creating a community manager agent. Okay, we can create an individual agent that is an expert creating Instagram posts, another agent that creates LinkedIn posts, and another agent that is an expert generating Facebook posts. So let's suppose that the user request is, please help me generating an Instagram and a Facebook post using the following information, blah, 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 blah. Copy and paste information into the agent chat. So the supervisor will analyze the user input. It will say, okay, the user needs to create Instagram and Facebook, a Facebook post. So I need to pass the control to the Instagram agent and the Facebook agent to solve the problem. And finally, when I have enough information, I can return the final response to the user. That are the Instagram post and the Facebook post. Do you remember that I mentioned at the beginning of this talk that the tools are also processing units? This is because there is a variant in the supervisor architecture. We can use tools for that to implement the supervisor, but using tools instead of nodes. So in this variant, we define a supervisor agent, which is responsible for calling sub-agents. Okay? The sub-agents are exposed to the supervisor as tools. And we can define the tools using functions. So the supervisor node will call the individual agents, passing all of the arguments, all of the parameters of the function to invoke the agents. Okay. In this architecture, it's pretty common to implement a while loop to iterate between the analysis process to decide when it's time to return the final response to the user. If I have enough information, I can return the final response to the user. But if I don't have enough information, I can call as many individual agents as we want or as we have. Okay? But what happens if we are implementing a supervisor architecture and we add too many tools to the agent, a lot of tools to the agent, a lot of tools at the supervisor disposal? So we will be in the same situation as the individual agent architecture using a lot of tools. So we will have the same problems with a single agent architecture because the supervisor node will start to make poor decisions, inefficient decisions, and obviously the context will grow and will be too complex to handle. So this is because in the hierarchical architecture, we can create specialized teams. We can group the individual agents and we can create specialized teams to solve part of the problems. Okay? All of these teams are managed by its own supervisor. Let's analyze this architecture. In this architecture, we are building a researcher agent that fetch information from the web using a deep research approach. So we could define a supervisor team to make search on the web. Let's call search supervisor. And this supervisor team will have a single agent to generate queries, another expert agent that will filter the information based on the relevance, and then we can also create another team to create a summary. Okay, let's call the summarization supervisor. In this team, we could have a content extractor agent, another agent that is specialized to make summaries related to the information that we have, another agent that check if the information is true or false. Okay, a fact checker. So in this architecture, we can, in this architecture, we have a top level supervisor that coordinates all of these teams, all of these sub-supervisors, enabling stable control flows and better management of complex systems. And obviously, for complex problems, for real life problems, we need to implement complex solutions because you understand that in the real life, the problems are not easy to understand, analyze, or create a solution to solve that. This is because we can implement our custom architecture. Yeah, in the custom architecture, the agents are added as node or tools because you know that the nodes and the tools are processing units, so we can use them to invoke the individual agents. And their execution order is defined ahead of time in a workflow. Okay, this approach allows us to combine elements from other architectures. For example, in a custom agent architecture, we can implement a supervisor, a hierarchical architecture, a network architecture, and our task as a developer is to coordinate all of these teams, all of these sub-architectures to work together and solve part of the problems to solve the general user problem, the general user request. So we can use the edges to make decision flexibles. You know, we can explicitly control the system flow or let the LLMs to decide specific parts, creating a balance between the structure and adaptability. This is true because if we are solving a complex problem and we have artificial intelligence, we can use that intelligence to pass the control to the LLM, to the AI models, to use their intelligence to create a path to solve the complex problem. We only define the the tools or the nodes or the individual agents that the artificial intelligence can use to solve part of the problems to solve the general problem. Okay, let's analyze this architecture. That is for agent that fetch breaking news and convert those into a podcast. Okay, so we could define a first agent to fetch the breaking news headlines. Then we can pass the control to another agent to rank the headlines based on the relevance. Okay, so at this point, we can identify, for example, three headlines that call our attention. Okay, and we can uh, execute in parallel many agents, many individual agents to fetch the news information. When we have all of the headlines, all of the news articles information, we can pass the control to another agent that is an expert generating podcast scripts. So with a podcast script in plain text, we can pass the control to a final agent that is an expert generating post podcast audios using text to speech technologies. Okay, this is an example of how we can define our architectures to solve a complex problem. Okay, I have prepared a demo to demonstrate the use of the individual agents. Let me share my screen. Okay. Okay. Okay, I have prepared this agent that acts as a community manager, as I mentioned in the example before, using the supervisor architecture. So I can interact with this agent to create a Instagram post, Facebook post, or a LinkedIn post. Okay, uh, let's say, please help me generating a Instagram post and a LinkedIn post with the following information. Okay, and this is the information about the multi-agents architecture and enter. Okay, let's wait for the response. In the background, let me explain you what happens in the background. The background, since we are implementing a supervisor architecture, the supervisor node is analyzing my request. It's analyzing, okay, the user want me to generate an Instagram post, but also a LinkedIn post using this information, the multi-agent systems, blah, blah, blah. So the agent will analyze the user request, will analyze the information that I provide, and we'll call the needed agents, the needed individual agents to solve a part of the problem, okay? And this is the response, yeah? The Instagram post and the multi-agent systems. So this post was generated by the Instagram post generator agent that is an expert generating Instagram posts. Okay, and this is the post about LinkedIn. Okay, and yep, let me show you. Uh, let me show you the workflow. Okay, this is the workflow. Okay, this point, the supervisor thinks, okay, the user needs to generate an Instagram post and LinkedIn post. So I need to pass the control to the Instagram agent, okay? When the supervisor retrieves the Instagram post information, then pass the control to the LinkedIn post agent. And that's it. Let me share my screen to continue the talk. Okay, so before to finalize, let me create a summary of the use cases related to the single agent architecture and the multi-agent architecture. Okay, the first is the single agent. It's we can use the single agent architecture to solve small problems. This is the key, small problems, well defined, where one perspective is enough. Okay, when we are attacking one problem, and second use case is to specialize in a narrow domain, becoming highly efficient and accurate in a specific task. Okay, when we are solving a problem that is a niche problem, okay, a specific problem with a specific domain. So this is because we need to implement a single agent architecture because it's now. And finally, when the environment is stable and predictable, so one decision-making process can handle all of the situation. In this approach, this is because we have a predefined solution, so we can go step by step to solve the user problem. So the environment is predictable, the environment is stable, so we call define single agent architecture. And finally, the multi-agent architecture use cases. Is to tackle complex problems that require multiple perspectives or strategies. Okay, remember that when we are handling complex problems, we need to implement a multi-agent architecture because the agent will analyze the problem and will create a path to follow to solve the complex problem. The second, when the problem must be decomposed into several steps or subtasks that can be solved in parallel. This is pretty common because we have a general problem or we are asking to the agent to generate many responses with many topics. So we can decompose the problem into a small task, and those small tasks can be executed in parallel using the individual agents. Finally, when the input or context is large and diverse, allowing a specialized agent to process different parts and then integrate the results. As the example that I showed you, I asked to the agent to generate an Instagram post and a Facebook post. So the context will be large. So I call decompose the problem into two separate tasks. One task to use the Instagram post generator and another to use the LinkedIn post generator. And then that's it. So thank you for your
Thank you so much, Willy, for this session. And thank you all for joining today. We hope you enjoyed learning something new and valuable. And we look forward to seeing you in our next session. So thank you so much, Willy, and have a great day.
Yeah, thank you so much for you and all of the people that joined to this meeting. Thank you for your attention.